we've got Yanan, we've got Jansel. Before either of them leave, I want to kick off the meeting with this topic, which is the move inductor FX passes pre-passes to Dynamo. So I'll go ahead and share the GitHub issue. I see the issue is closed, but I just want to, even if there's already a resolution, I just want to socialize what the resolution was. What did I share? I shared my entire screen. I don't want to share my entire screen. Okay, let's see. Yanbo, Yanan, or Jansel, which of you wants to sort of present the basic like premise here?
I can give introduction actually.
Yeah, that sounds good. Please do.
So essentially, we're trying to integrate export with the AOT inductor, and you'll realize that some performance critical passes on AOT inductor are written on Torch IR, which is not something TorchExport currently produces at all. So we were discussing options on how to deal with this abstraction level mismatch. And one way is we make these pre-grad passes default in Dynamo, i.e. making Dynamo taking on some of the optimization responsibilities. But this will, they're harmless passes, but this will make Dynamo's responsibility less clear. There'll be more than just graph capture to solve our problem. And sorry. And Jason pushed back exactly because of this. I think Dynamo should strictly be about graph capture rather than doing anything that's performance related, which is a very good point. So we're discussing options, and Jason and I had an offline discussion as well. And our eventual solution is to expose Torch IR for several reasons into as part of the output of some TorchExport. And essentially, the TorchExport produces a export program object, and in there we're still gonna mainly encourage users to use A10 graph for the moment, because at PDC we cannot afford to make excessive BC breaking changes right now. But there will be an attribute on there that says dot torch IR, and the user can get the torch level IR graph, and they can do these AOT inductor pre-graph passes there. So that's the solution.
Okay, do we have questions from the room? Questions, comments?
Wait, so I don't understand that. Why not just port the inductor passes to pre-AutoGrad A to IR? Like this seems like the most natural solution to me here, rather than expose like another level of IR for users to work on.
So I think we should do that. Like we should be porting as many passes to the IR as we can. But I think for like an API design, I think there's a pretty huge advantage to having torch.compile and torch.export produce the same IR. Like, because then, because like Inductor isn't the only backend for Dynamo. There's lots of backends in Tree. There's a bunch of other companies building backends as well. And so if we have sort of a uniformity where compile and export produce the same graph, you can use all the same backends, you can use the same library passes, I think there's huge sort of like ecosystem benefits that and composability benefits. Because
I'm totally on board here, but what I think is that the IR they should be producing is a pre-AutoGrad A10 IR.
So I think doing an IR change at this point would be pretty BC breaking, and I think like what we can do is we can like expose it as a flag where you can like opt into that new IR, but I don't think we should like switch out the IR under people's hoods, because this is a BC service.
I'm not sure what the BC service here is for export.
So maybe I have another document. Michael, do you want to say something first?
Sorry. So Torch IR being like the non-A10 IR. So I guess like what we get out of like Torch NN tracing, like FX symbolic tracing. Yes. Yeah, I mean, I just have concerns about the portability of such a representation, right? Kind of defeats the purpose of export if the primary way that we define each of these things is like in Python. So I kind of agree with Horace that like if we have to pick one, it seems pretty clear to me that we should pick the Predispatch A10 IR and just change compile. I think that BC is an issue, but like it's also not, like the whole thing is JITted, right? So like it's not like we have fragments of this IR running around. We do have to update backends or something and figure out how to do that, but that's actually a lot easier than the alternative, which is having sort of a break against like an IR representation that we commit to and serialize, which is what we do when we do things AOT.
So, but I guess the issue, the BC issue is, so currently we have FX Symbolic Trace and we have Torch Compile, both of which are producing the same Torch IR. And there has been a lot of community adoption of writing FX passes on FX Symbolic Trace. And there are I've talked to a bunch of accelerator manufacturers and people like basically building Torch Compile backends today. And so I think the like if we were to change FX Symbolic Trace to produce a new IR, we'd break all the FX passes in the ecosystem. We'd break all the FX passes.
Do we actually break all the FX passes? Yeah. Sorry, go ahead, Horst.
I just saying we're like I don't think we're proposing to change FX Symbolic Trace. We're just proposing to change what Dynamo produces.
But I guess I feel like having Dynamo produce the same graphs as FX tracing is a big composability advantage. We have one IR that both systems have.
I don't know. It is multidimensional. Like when we talk to most vendors, they're still on TorchScript. TorchScript is like an A10 IR that's pre-dispatch. So it's like it's hard to really say what is like more VC breaking or not from an ecosystem perspective. What I don't want is like a proliferation of like, well, we have FX Torch IR, which is different, by the way, than Dynamo's Torch IR. They're not like really the same. And then there's export, and then there's TorchScript, etc. Okay, but there are hands. I don't want to belabor this.
Yeah, so I want to say there's one thing that Jason's argument moved me is basically we do have real users who would very much like the Torch IR level of abstraction. They want to see modules there. And we talk with accelerator vendors, and they want to see, oh, I want a more composite op. And when we talk to the quantization team, and their face just light up when I say maybe we can produce Torch IR, because that solved a lot of the problem. They have a big problem for reliability, consistency between from NN modules to A10 ops. So that is useful for them. And I said I have a doc to show you guys. Let me pull it up. So this is what I plan to do for the changes, and it puts Torch IR as available, but not necessarily at the most prominent cases at PyTorch conference time. So this is what we have today, essentially. Export, removing all the other details, in essence, it's called Dynamo Export to generate Torch IR, and then AOT Export to generate A10 level IR. Here we do the core A10 decomposition now. At PyTorch conference, I plan to make some changes. So this is what users will see at PyTorch conference. There will be Dynamo export where you say A10 graph is false, please patch it out. So you still get a Torch IR. And you get A10 level IR, but decomposition table is empty. Meaning that we try to disable a lot of decompositions where users can get more freedom in decomposing their ops. And the return object will contain both. But the default accessible one will be the A10 level IR, but Torch IR will be accessible via, say, property.
But this is crazy, right? Like,
why?
You're seeing two different representations in the same export that are like have very subtle differences between each other. Like, can we just do one? Like, what is going on?
I just also want to mention that on the sort of JIT like compile usage of Torch Compile. Realistically, if you actually want to support AutoGrad, you have to use AOT AutoGrad, and so you never get to have Torch IR. You're always getting the post AutoGrad A10 IR at that point.
Yeah, that's it. Today, A10 IR is inference only. That is also a big restriction that's worth knowing. Where if we go with A10 IR for export, then until we make some major improvements, it'll be an inference-only IR that's completely unusable.
Wait, I thought Ed was saying that's the case for Torch IR.
No, that's the case for A10 IR. Because if you call makeFX to get A10 IR, and then you call AOT AutoGrad after that, that's just completely broken today. And so
I mean, this is the purpose of like the pre-dispatch A10AR. Like, I don't think.
Yeah, but that's pretty. So I think like basically we have the system.
Why are you saying it's broken today?
Well, I think the pre-dispatch stuff will fix it, but the one that we're using today is post-dispatch, right? The one export return.
Yeah, we want to do pre-dispatch IR. I think everybody agrees. That makes a lot of sense because
I think what Jason mentioned is the status quo. We don't have pre-dispatch IR today.
Yeah. So like so like the A10 IR that's in the wild right now is an inference only IR.
Wait, but so on this question of like, if you need AutoGrad support, you need to go through AOT AutoGrad, and as a result, as a backend, you're consuming A10 IR, not Torch IR. So what's the like? Which backends need specifically Torch IR and not need to support AutoGrad?
No, so Jansel is talking about a different case than what I was talking about. He's talking about export. I want to export a graph and then train it later. And for reasons I suppose I can't use the AOT export joint thingy, which is what we are using for this use case.
Or like, I think this is like a reasonable case. Like, for example, this is like, I think, what you often want for things like quantization. But I still feel like we should just unify on the pre-dispatch A10 IR and commit to that rather than, potentially fragmenting into a case where we have 3 different IRs. I think 2 IRs is already not ideal. and so
I strongly agree with this.
So I actually argue that like if we are in a case right now where we don't have 1 IR, we don't have 2 IRs, we have hundreds of IRs because there's like so many flags you can pass. You can choose, like, you can enable and disable every decomposition, you can do pre-dispatch, you can do functionalization, you can do functionalization with the input mutations in the graph, without the input mutations in the graph. Like we are in a case right now where we have dozens and dozens of IRs.
There are like changes in like what the ops are in the IR, but then like the difference between like what a Torch IR is and what an A10 IR is completely different. Like at the A10 IR level, like at least every single thing is call function, like every single thing is like an A10 op with that defined with like the A10 dispatcher. In the Torch IR, you have like methods, you have functions, I think you have modules, and I think like the divergence in IRs here is like on a pretty different level.
Yeah, so I agree, but I think like what I view is like we have a system right now where we have dozens of IRs out there, and there's like pros and cons to all those IRs, right? And like I agree that like standardization is good, but there's also lots of IRs that are used in today. And so in practice, like what I think is I don't think the most important thing is to unify everyone on 1 IR, because I think in practice there's real reasons why people are going to want different variants of these IRs, and the different variants are good in different places. I think the key thing is that you should be able to convert the thing returned to export to the IR that you want, right? So basically, like if you're given 1 IR, you can sort of draw a graph of like what IRs can I convert to what other IRs. And basically what you get is you get lots of these normalizations, throwaway information. Like I can like run a bunch of decomps, but it's really hard to unrun those decomps. Like you can't unapply these normalizations. And if I look at the big advantage of Torch IR is I can take Torch IR and I can convert it to every other IR in the ecosystem, and there's no other IR that has that property.
I think that. Oh, sorry. Okay, let's give
Kimish a chance.
Yeah. So I just want to clarify something on the quantization side. So the pre-dispatch AutoGrad IR that it wants to use is to use eager mode AutoGrad engine, not necessarily the same as, I don't know if the AOT AutoGrad gets like a joint graph versus separate forward and backward graph. This is slightly different than that use case. Just want to highlight that. This second thing I want to ask was about the need for recomposing the already decomposed ops that Jason mentioned. Is this with like what's the use case here? Is it because some backends or accelerators want to understand how can I map like in some multi-headed attention module that gets decomposed, and I actually have an efficient implementation of that, and I want to map to that. Is that why we are talking about being able to recompose from an already decomposed IR?
Jason is saying decomposing is a bad idea, which I think most people are in agreement with. Like you're saying you don't want to recompose.
Yeah, I think, so to me, it's not, I think I totally agree with the idea that like, well, you do kind of want the first stage IR, the thing produced by our front ends, to be like flexible enough that, you know, backends can, that they can actually decompose like based on what they want, right? Like if you want to keep a certain thing. The only question in my mind is like, should that be pre-dispatch IR or should that be torch IR? My argument for pre-dispatch IR is I think it hits the sweet spot of like it's sufficiently regular in structure. It has a very important property, which is that it like actually represents like an interface that we have in our system, as opposed to torch IR, which does not. And then like the A10 dispatcher principally, and then and that gives us a lot of good properties with respect to being able to execute it without relying on Python, for example, which is a very important property. Like I can tell you in practice what will happen if we ship Torch IR out of export is that there will need to be another stage in the system where we just convert it immediately to pre-dispatch IR, which maybe is fine, but then like I don't know what we're buying getting Torch IR. As far as I understand, it's more difficult to work with than, you know, pre-dispatch A10 IR because of the existence of methods and modules and state and like non-functionalness, etc. So like people who are writing passes based on that, those passes are probably broken, right? Like I don't, you know, we have a lot of experience with these symbolically traced IRs, and people don't like it doesn't scale very well, right? This is kind of like why, you know, for on the production path, we want to get rid of our symbolically traced IRs and unify on like a more regularized thing.
Yeah, I'm not arguing that like people should be writing passes on Torch IR. I think there's a lot of issues on it. On the other hand, like I do think like a lot of people really like FX passes, and like, you know, you look at like there's a bunch of internal teams who've written a lot of FX passes. They like how easy it is to work with FX graphs. They like working with modules. They like that it like looks like the input program. So there actually is like a lot of there's a lot of evidence that like there's people who like the IR that FX produces. But you know, I think like, you know, in our documentation, you know, what we should say, I think like the design I see is we could either have a unified function which both exports and lowers it, or we could have two functions where you have export and then you have like the normalized IR function. And in our docs, we should say we could very prominently say like, oh, like you should call this normalized function. And the problem is, just having the two functions that do the two separate things is strictly more powerful, because like we can't really write like the unnormalized IR function. And so I think it's more flexible. It like if we were rewinding 2 years ago, like before Torch.fx.symbolic trace existed, and like Torch IR didn't exist, I think you could probably convince me that like we should make a change in it. But I think that like Torch IR is an extremely well-established IR that's used in lots of places. A lot of people really like it. And saying to people, no, you're not allowed to use Torch IR anymore, we're taking it away from you, I think is
yeah, I think I think that part makes a lot of sense. I mean, part of the thing that I struggle with there is that like Torch IR isn't one thing. So we're talking about like Torch IR and we're taking away Torch IR. The reality is, you know, like if you look at internal users or just like regular users externally, you know, it's not Torch IR, it's like ACC ops or it's the deeper tracer ops, right? These are not fully specified things. If we export them, they're essentially meaningless because half of their definition is in a Python script. So like this is the problem with like allowing that as an exported thing. So if we say Torch IR, for example, is more restricted and it's only stuff that we allow, we still are taking something away from them. We're taking their ability to module swapping on leaf modules, which is the thing that they actually want out of this thing. The thing that they want is the ability to like arbitrarily define like opaque sections that they then, you know, have in Python, right? This is what people use in the actual like graph lowering and transformations paths. It's actually unrelated to Torch IR. It's just like the fact that they have flexibility as to the sort of tracing mechanism. Now we have to figure out how we're gonna, you know, help people with that too. But like, Torch IR isn't one thing, right? Like if we say it's what comes out of FX symbolic tracing, then we have to talk about FX wrap. We have to talk about FX leaf modules. And those just basically open up completely the space of what that graph can mean in a way that is like actually you lose power from exporting that because now I don't have leverage over the set of things that are exported.
Yeah, although we are doing sort of equivalents of fx.wrap for and like defining leaf modules in Dynamo. And so like I agree, like module swapping is like the common use case, is one of the common use cases. And like you can also do module swapping with the IR produced by Dynamo.
Elias?
I just wanted to point out real quick, Michael mentioned like pre-dispatch or Torch IR having mutation. Like as far as I know, pre-dispatch also is going to have mutation as per the current plans. Brian can correct me if I'm wrong.
No.
We're going to functionalize pre-dispatch and it'll
Oh,
happen.
we are going to functionalize? Okay.
Yeah.
Okay, cool. That's good to know.
Kimish?
Sorry. All right, sorry.
Oh, Horace, you want to say something?
I was just gonna ask a bit, like, is the Torch IR produced by Dynamo even serializable? Like,
No.
Okay, then I guess I'm slightly more confused now about the purpose of producing it from export. So, the graph produced here is non-serializable, but you want to export it, and then what's intended use of this IR?
That's why I say it's accessible, but we won't recommend using it only if you need it. And when you want to save it, you have to call lower to A10 to get the A10 IR and then serialize. It's a confusing concept, but okay, since I'm talking, I want to say this is essential. If we take away immediately, and I saw the real use cases where they need Torch IR, where they need module level representation, then if we take away immediately, then it's like shock therapy. If we do this approach, we do not advertise it, but it's accessible. We can, let's say in a few months, observe users' behavior, see how much they actually use it. And if they find A10 IR more useful, then we can, and no one uses Torch IR, we can remove it. Otherwise, it may have to stay.
Yeah, I mean, there's simple use cases like you export, you do a module swap, you lower to A10 IR, you save it to disk, right? That's something that seems totally reasonable to me.
Why wouldn't you just do the module swap first? You have access to Python. Since having access to Python is a precondition of using the Torch IR, there's no reason why you would do that module swap after the fact. Like by construction, you must use Python in order to do this, right? So there's no point.
Or I can maybe sympathize with the idea of kind of, if you want to position like some kind of export as basically a replacement for fx.symbolic trace, I could see this as like a reasonable thing. But I do kind of view this as like a separate thing from what I've typically thought of for export.
But I also want to add that the module swap is not necessarily, and one, I understood that module swap should be also possible with the pre-dispatch IR or whatever the you subsequently. It's not necessarily that only the at eager mode level you actually do this. And this actually also relevant when you want to compose other stuff like quantization with delegation, especially on the S stack, you do quantization first and delegation. At that time, you might want to say that, okay, hey, there was like, some multi-attention that I quantize end to end both, and then I want to recognize that and swap it. So he's not going to be able to do that like, at a high level. So being able to recognize that this subgraph represented some torch module is independently needed. And it has to be, and wherever it's needed, it should be composable with the other parts of the system, including things like quantization.
Ben?
Yeah, just want to raise one possibility for this, right? Like Yana mentioned at the beginning, the motivation of this whole thing is actually there's a specific problem we want to solve in AOT inductor. Like once we take the IR from export, it's not going to do those like Torch IR level transformations. Well, is it possible that we just take a hit at this version and say, okay, we'll drop those, right? In AOT inductor, and then we'll waiting for those transformations to migrate over to the Torch the IRs at lower levels, right? So that's just another possibility I want to raise.
Yeah, I mean, that is the motivating use case, but I worry there may be more. So my tendency would be we release it and see in real world how people use it.
Yeah, I would say like the real world. How do you define that, right? Like once when product uses this, and it will exist forever, probably. Like you just need one single user.
Oh,
Yeah,
it's a new thing, right?
it's a
People
little
are gonna,
backwards. I feel like
yeah.
you don't release a secret IR to like try to figure out if people will use it. Like, because I mean, if they do, if at least one person uses it, then someone uses it, and then we
No.
have to support it.
If
Wait,
it's
sorry.
up, yeah.
Can I propose maybe a more wild pitch, which is we add another API called torch.export.symbolic trace and kind of position it as a replacement for fx.symbolic trace.
Isn't this just fx.symbolic? Like, what's the difference? Why can't people just use fx.symbolic trace? We're not getting rid of it. Like, it still.
I mean,
you can still use it
I
if you
think
want.
The
like,
primary distinction is that it can trace more programs because you're keeping track of meta information, so you can resolve queries on sizes and things like that.
Okay.
Yeah, it can trace more things. I'd also argue that you know, so I wasn't aware previously that we were planning to functionalize. So I think there are real use cases where people might want to export a non-functionalized program. Yeah, there's cases because like there's a lot of types of things like, you know, if I have like custom external calls that don't functionalize today, so there's like errors in functionalization. But also, you know, there's use cases where, you know, I might have carefully added some mutations into my program, and I want to export that and have a high fidelity version of that. And so I think yes, like for all the compilers I want to write, I want functionalization. In some cases, I want like functionalization except for these like exceptions, like, you know, input mutation or, you know, scatter operations. Yeah, I think just unconditionally applying a specific version of functionalization is also pretty limiting. And it's something where if we just have like a more composable system where you you just have two separate functions, then we're not actually losing anything, because like these things like functionalization throw away information, and then it's really hard to recover that thrown away information. And I don't think we should be by default throwing away a ton of information that could be useful to the user.
Vaz?
Yeah, maybe this is a dumb sort of view into things, but it always seemed like the output of export should be the same as the contract for when you pass a backend into Torch compile. Like, it seems like if I have a backend as something that's callable, shouldn't matter if the input came because I passed it to Torch compile or Torch Dynamo optimize, or because I called export upstream somewhere and then passed it in. And it seems like if part of that contract is having the same IR, then you can't really sort of limit one and not limit the other or deviate from that contract. But maybe that's not a useful contract. I don't know what people think.
No, I mean, it's
what's that same IR in your mind though?
What did you say?
What's that same IR in your mind though? We had the idea of either using Torch IR, which was there today, or we move Torch compile to Predispatch IR, which is another idea.
Yeah, I'm not proposing one or the other. Today, it's pretty clear what it is. I'm just saying that in my mind, these are bound.
Yeah, I think it's definitely a desirable property. I mean, I will say, like, do we plan to allow Dynamo to produce different kinds of Torch IR depending on the backend? Like, can backends hook into how Dynamo is working to change how it works so it produces a different kind of Torch IR?
I'd argue that like we should just have the backend call like normalize IR as the first call, the first line of their backend.
But you were talking about how like people like Torch IR because it's flexible, but if they're going through Dynamo through torch.compile, do they make use of that flexibility by customizing how Dynamo will be tracing? Or is Dynamo producing something regular that backends are supposed to target?
So currently Dynamo produces a single regular graph with the exception of sort of like the allow and graph stuff. So people basically, which is basically the same as like the leaf module stuff in Symbolic Trace. So people can customize Dynamo by doing like allow and graphing things. Mm-hmm. You know, for the backend, I think today that we just have one IR that it produces. There's no like configuration flags, like, you know, here's what you functionalize, here's what you functionalize, here's what you become like there's no, it's just one standardized IR. And basically
so
the
we have to
idea
make just some decisions about what we're going to functionalize and not functionalize, right? Like we're not going to make that totally open, right? Like we want to standardize the IR out of compile, right?
Yeah. I think it's standardized today, right? There's no configuration flag. There's no like global configuration flags that really change the behavior of what's produced. There's one standard IR, and that sort of standard IR is sort of the top IR that can be converted to any other IR. So it just preserves maximum.
But like, wait, you said we also want things like leaf modules, right, and stuff like that.
Yeah, but that's changing the program. So you change the program to say allow in graph X, and then
Right, so allowing graph is not the same thing as leaf modules. Like
it's a similar and related thing. It's not exactly identical, but it's
I think the crucial thing about like leaf modules is you can then do module swapping on that leaf module, which is not true for allowing graph. Actually, I think allowing graph is actually. Or sorry. Wait, no. Maybe it works if you put on the module.
It should be true. What wouldn't work?
Sorry, never mind. I think
doesn't get preserved as a call function. It's not like a module qualified that you can actually swap.
No. Like there is a little known ability to use allow function on the module definition.
Very exciting. Yeah. Okay. So my basic point, and I know there are hands, so I feel like maybe I'll just say is like I think we all agree that we want some sort of opinionatedness about the representation. So Torch compile isn't like infinitely customizable, right? Like it's going to produce something that backends see. Then that we kind of want that to be relatively flexible, which is to say that backends can then decompose however they want. We don't make that many decisions decomposed about like decomposition because recovering structure is hard when you've removed it. I think and we also kind of agree that export and compile should produce a similar representation or the same representation ideally. I think the biggest problem is, so it's really just like pre-dispatch A10 IR versus Torch IR. It's not really clear to me exactly what the differences are. Like, are the differences substantial or is it only on like a few modules like linear? Because like, you know, Jason, sometimes you mention, like, sometimes you're talking about like customizing the tracing process entirely, which I don't think is what we're actually talking about. Like, that's kind of nice, but then they should just use FX symbolic trace and do some random stuff, right? Like, that's fine. We're talking about the output of compile and the output of export. We actually do want to make some choices there, right? About what we functionalize, what we allow in the graph, what we don't. And if users want to customize that, they have to change their program, not the tracing system, right?
Yeah.
Yeah.
So I think I think that's true. The initial like I basically view like the graph produced by Dynamo as analogous to symbolic trace. Like they should be the same, and you can do the sort of similar stuff with like I think we should actually unify allowing graph and wrap. I think there's a ticket about that as well. Just because they're very similar concepts, and we should make them one thing. But basically, like but you know, users can like the customizations that are done in Dynamo are done pre-Dynamo tracing. Basically, embody themselves as program changes. Like you add the allow in graph decorator. There's like a few others like assume constant results that you can put in there. But then once you get that, you get a sort of a standardized IR that's like not sort of backend customizable. Basically, that's your API abstraction boundary where you have, you know, many ways to produce the IR. You have symbolic trace, you have compile, you have export, and then below that IR is sort of all like to the first approximation the same. And then below that abstraction boundary, you can have many different things you can do with that IR, and all of those can sort of make different choices, and at that point you can like decide to function.
Yeah, so I think the picture is identical. It's literally just whether we want it to be at the A10 level or at the Torch level, right? Like that's.
I feel like we already made that decision 2 years ago.
But we've made this decision like many times, like, you know, with the JIT it's at one level, with Onyx it's at one level, with FX it's at one level. So there isn't like a decision. We have to make this decision, right?
Well, I think what it is like we could change it. Like we could decide to say, okay, Torch compile produces a new IR now, but like that would thrash users, right? Because it's basically we're changing our IR yet again.
Wait, so are they not behind AOT AutoGrad? Like, what do backends consume?
Backends consume whatever they want. Like some there's
but what's the standard representation that we expect backends to consume? Is it AOT AutoGrad?
So if you actually care about supporting AutoGrad, there really isn't any practical choice besides AOT AutoGrad.
That means it's A10 IR, not Torch.
If you're
IR,
inference only, you probably
if you're
can
inference
consume
only, you
Torch
want
IR.
A10 because it's all defined in C++. Like what is going on?
For example, like there's a bunch of researchers who are like,
okay, like sure. I okay, sorry, please continue.
Yeah. I mean, so there's a research paper that's sort of talking about some like batch norm rewrites. And the way that works is they find the batch norm module and they check properties of the batch norm module, and then they call inductor afterwards. So basically, the way their backend works is they take the Torch IR graph, they do a bunch of pattern matching based on batch norm module call module instances, and then they call inductor after that. And like that's,
I'll be honest, I'm okay churning those researchers.
Yeah.
Like it's not great. I totally agree. But like if we had to pick one to churn, I'd rather churn them.
But I guess like pre-dispatch IR at this point isn't done. It's still really half-baked.
Yes.
So like, and this is the kind of thing where like every time we make an IR change, we thrash users, we hurt BC, and like I don't want to take like a half-baked IR that we're not even done finishing and like we're not like and just like shove it out as the default for Torch compile. Like I think that like maybe at some point in the future, once it's like really stable, we're really confident we're not going to need to change it again, then like we can talk about making a change. But like today, like A10 IR is an inference only thing. It's like really not an option.
Yeah, I don't think anybody's really suggesting that we like directly move compile onto pre-dispatch A10 IR today.
Okay, I'm putting on my moderator hat. I want to clear out the hands queue, and then I want to try to like come to a resolution. So Horace, go.
Okay, I guess I'll just like I want to comment a little bit. I think about like the moral intention behind fx.symbolic trace, and I feel like there's kind of a distinction between how fx or some of the invariants around fx.symbolic trace and what I think you would expect from an export API. And I think the kind of moral intention behind fx.symbolic trace is that it returns you a like honest to goodness Python or like honest to goodness Python nn.module. Like the idea here behind fx.symbolic trace was that like it is not like a lowering of any kind. It is kind of a direct one-to-one translation between like user nn.module written to another representation that they can then just treat as any other nn.module. Like everything that you would typically expect to work with an nn.module, you also expect it to work with the fx.graph module. And I think there is value to this. Like, a lot of the things that, people are mentioning, like, the like batch norm, rewrite, whatever, like things like this. And also just the fact that you can then, pass the fx.graph module to things like torch.jit.script or other things are like good, nice properties to have, so to speak. But I feel like this is a like meaningfully distinct use case from export. So I feel like I'm okay with having a replacement for symbolic trace, but I feel like it should not be bundled together with export as an API.
Okay, Kimish, I saw you load your hand, right?
Yeah, I just actually now you call it out. I just want to ask, like, isn't there another way of keeping the lineage of information around? Like, you started from some top level module. There's some you wanted to understand how that module was called, and when you get decomposed, that information is not preserved anymore. Isn't there any other way to have that information? Because this is definitely also a place in a lot of other places.
It's possible, just hard and complicated.
Okay.
I assume you're talking about the NN module stack meta annotation.
Or whatever metadata, like, I don't know if that is meaningful.
Yeah, okay. I think this is orthogonal
reliable
from the philosophical discussion right now. Okay, so the way I want to run the last 15 minutes, and we're not going to get to any other topics because I think we need all of the time, is I just want to get some agreements about what questions we want answered and then try to answer them. So, okay, so there's part of the problem is we're trying to solve for a lot of use cases all at the same time. And Elias, what's up?
I just want to point out that, like, for some modules like LSTM, for example, like we don't have an alternative, like we don't have a non-Torch IR representation of loops right now. So if we were to like lower to pre-dispatch, like that would just like completely, yeah, there's no alternative way to represent control flow right now. The only way to do it is with Torch IR and a FX wrap.
I think there's an
There will be though. There will be.
But,
or no,
yeah,
there
it just doesn't
is
exist.
No, like there's an A10
What's
on
that?
LSTM. There's like an LSTM op in A10, I believe. Like
if you mhm. I mean you can move the entire like module to an operator, yeah, but it's not like the same, not exactly the same thing.
Okay, I don't think this is going to materially affect the rest of the convo, so I'm quashing this. Okay, so, but this is actually, it is a good segue. So I think one question that people are asking is the IR produced by FX Symbolic Trace, referred to as Torch IR, a useful concept that should be exposed by our system? And many people in this meeting have argued yes. And many people like Horace have said, yeah, I can see where you're coming from when you're talking about symbolic trace. So are we okay with resolving this question to yes? I am separating the should export do this by default and the should torch compile do this by default as separate questions. But do we agree that like conceptually this makes sense and there might be some places in our system where this concept shows up? Okay, I'm resolving it this way. So my second question is what is the contract on this Torch IR concept, which could be used in export, could be used in compile? What are the contract, what are the things we're going to uphold for users? What are valid changes we can make to this specification? And to see the discussion, I can propose a few things that I heard during the discussion just now. So one is that, and this is from Horace, the IR should as faithfully represent the original Python user program as possible. So like, if there is a way to like swap between calling something with kwargs versus not kwargs, you should still represent that. Like there is no normalization that goes on because normalization destroys information. So another way of encapsulating this is it should have as much information unnormalized as possible. Do people agree with this part of the contract? Does anyone disagree with this part of the contract? Okay, can people tell me what other parts of the contract are based on the discussion we had? So here's a non-contract. The IR is not serializable. This is not part of the contract. We do not expect to be able to serialize Torch IR.
I would agree with that.
Why it is a contract?
It's the contract because, like, if the IR, if we wanted to guarantee to users that this IR was serializable, then we would have to make sure that we never put anything in the graph that we can't actually serialize. And that includes, additions like allow in graph and things like that. So like, maybe you disagree. Maybe it's like, oh, but for export, Torch IR, I do want it to be serializable. But, then we should have this discussion about like what the valid contract is. But I think like people have said during the meeting that for very good technical reasons, it's very difficult to actually serialize Torch IR because it's just arbitrary Python callables everywhere.
Yeah, I think the existence of allow in graph or like fx.wrap makes like the general case impossible. I think like the common case is probably like pickle probably works.
Yeah, it's less of an element of the contract as it is just like a technical fact that we can't serialize.
Or actually, no, so I actually do view this as an element of the contract. Like I feel like a big part of like the purpose of fx.symbolic trace, like I feel like fx.wrap is not like a minor detail of fx.symbolic trace.
It's fundamental.
I feel like it's a pretty fundamental like use case for it.
Yeah. So I think this is agreed.
Okay. I think another part of the contract is the IR should faithfully represent the NN module hierarchy. Because people were talking about module swapping. Actually, I'm not sure if this is true or not.
So I think in practice, people don't actually care about faithful representation of the NN module hierarchy. Typically, the way that they trace is coupled with the way that they want to transform. So they'll wrap something in a leaf module so that they can swap it. So they want the ability to customize the module hierarchy according to their desires, if that makes sense. And they, you know,
I'll buy that. Okay, so is modification accepted. Okay, are there any other things part of the contract that we give for Torch IR? Okay, so I want to move on to the next question.
Sorry, I like. I mean, perhaps this is like obvious slash like, or this is perhaps implied.
No,
by
that's
the first
fine.
Point,
obvious is fine.
It should be like, you know, convertible then to like you should then be able to retrace it slash recompile it, re-export it down into pre-A10IR or A10IR. And so this includes other things like you should be able to AutoGrad through it. You should be able to perform other transformations through it. You should be able to, you know, pass, you know, tensor subclasses through it or whatever. Like it is like it should be as much as possible. Like anything that you could have done with the original NN module, you should also be able to do with this an ender module.
But this can't be contractually enforced, right? Because of the existence of leaf modules and FX wrap, right?
No, so why not? Like,
if you're allowing something that's either not safe or not possible to be compiled, exported, traced.
And then the programs are not possible to trace from the beginning.
No, like, sorry, the property here, if you could compile the original module, you should be able to compile the Torch IR traced version of this module.
Yeah, that is a weaker guarantee, but yes, that makes sense.
It's more like treating it as just another callable.
This is fine and consistent with FX. Jerry?
Yeah, can you also talk about what is the guarantee around like stability of the traced results? Like, let's say if I have the same model where I always get the same representation every time, or like no matter which PyTorch version I have, the one and the other things, if I trace it with different inputs, will I always have the same representation?
So for the second one, I can definitively say no, if only because like if you change the shape or the dimensionality, the way dynamo tracing works is you will get a different trace. And this is different from symbolic trace because in symbolic trace there was no way to, you know, trace the program at all if you depended on the size. But Dynamo would be able to trace that, so you would differ in this case. For the first question, which is will I get the same rep no matter the PyTorch version I have? And let's assume that the PyTorch program doesn't change. I guess this mostly depends on where you set the leaf modules. So like if all of the functions and modules that are part of the PyTorch public API count as leaf modules, then I think you can say yes to this guarantee. But the moment you start inlining into these, obviously we can change the details of how a module or a function are implemented, and then you would expect the error to change in this place. And I don't see how you could like basically give this guarantee otherwise.
Yeah, I would say in practice we cannot give a stability guarantee. Just because like the carve outs in production models, at least for leaf modules, are really substantial.
Are we okay with resolving this as no, but with some nuance? Okay, resolved. All right, so now I want to bring this back to the original problem that got us here, which is export. So there are a few ways to pose the question here, but let me ask some like very specific questions first, and they might be too specific. So should torch.export.export produce torch IR? Well, let's do Yanan's proposal precisely as a private attribute on top of exported module along with the A10 normalized IR.
Not exactly private, but more like a
undocumented attribute.
Yeah.
We
can document it actually.
Just matter of just like design, I guess. It's weird to have an entire representation that technically we would then like need to not really break as something, let's say, under-documented. You know, we should
are people against my idea?
Yeah.
So let's put Horace's idea, which is instead have torch.export.symbolic trace, which produces torch IR like FX symbolic trace.
And we could also have like torch.export.normalize, which converts torch IR to the pre-dispatch IR, and then the convenience function, which is calls them both.
I personally prefer bullet 2 over bullet 1. Yanan, what is your feeling?
So this is essentially splitting the export call into two? Calling symbolic trace first and then
we're basically
normalize.
saying torch IR is a useful concept, and it's not what we're thinking of as export. It's not serializable. It, has very few stability guarantees, but it's convertible. So it seems to make sense that this should just be its own API.
Just point of order, like, is TorchExport normalized the same as TorchExport? Then, if it's converting torch IR to pre-dispatch IR, I assume it's doing that by retracing.
So torch.export would just call torch.export symbolic trace followed by torch.export.normalize, and so torch.export would just be two APIs combined into one API.
But in that case, we may not as well just not expose torch.export anyway because we have a more unbundled version of it.
Yeah, it would just be a convenience function. Or either not exist or just be a convenience function.
So, Michael, I think the distinction here is that export normalize takes an FX graph, whereas torch export, as it exists today, takes a callable.
Right.
Okay, do we have a resolution to this question? Do the people in this room think we can come to a resolution right now, or do we have to talk about it more?
I guess my biggest question is like, why don't we just leave symbolic tracing? So you was suggested that like we can do a little bit more with torch, like dynamo tracing, but it's not a strictly more powerful thing, right? Like
it's not strictly more powerful.
It's less powerful.
Yes.
Yeah, like it's a trade-off. So like, do we really want to introduce another API? Like, can't they just use FX? Like, who is the individual person who would not want to use symbolic tracing today, but wants to use Dynamo, but doesn't want export? Like, I don't know of a person who is that person. So
for any dynamic control flow users, they cannot use FX symbolic tracing as it today.
But that's then I think the answer to that is we should just like have FX trace our symbolic control flow up, right? Like that's not that hard.
I mean, the use case that started all of this is people wanting to call inductor, because inductor, at least today, contains a bunch of torch IR passes at the top of it, the basic
inductor can take
inductor wants like torch.export.symbolic trace without the normalize.
Wait, but inductor can just use symbolic trace, right?
Yeah, people could just use symbolic trace with inductor. Yeah, that works.
So I think that's okay.
But yeah, I think that's fine if they're programmed symbolic traces. There are programs that don't FX symbolic trace that do Dynamo.
Yeah, but I mean, there's both of the other. Like, I don't think it's a clear win actually.
Yeah. So having both APIs would be useful, where you could like call export Because if one fails, you could use the other. Right?
You know, we would add like another tracing API to our 5 tracing APIs and be like, it has
more complex, more choice, and
I don't know. Like maybe. I'm not convinced that's actually like a good expansion of our API.
Jiangshu?
I just feel it's a little bit more confusing now to user to have like, you know, TorchExport and Symbolic Trace. But I agree that they are not the same thing. They don't provide the same contract. So I don't know what to do.
Yeah, concretely, I mean, one of the things that we need to figure out is like, how do we package it up for users? Because part of the point of export is that you produce something that you can actually take somewhere else. So, and for that, you know, we have to make a decision at the representation so that we can, you know, safely decouple like front-end concerns from back-end concerns. So right now, Inductor is a little bit violating this because it wants the Torch IR transformations. And so this entire thing is because like, okay, we need to produce a representation of that Inductor. If we can fix Inductor, not fix, if we can change Inductor, I won't put a normative spin on it. Like if we can change Inductor to take pre-dispatch A10 IR, then this is not a problem, right? Like we can just, it's fine. Like we don't need this extra API. We can just use FX Symbolic Trace.
Yeah, I do want to revisit the first question that Ed put forward though. Is Torch IR useful? And the answer is yes. So even if AOT Inductor can move away from it, and I think we'll agree on it's still useful somewhere else.
Yeah, but if it, you know, if it's useful, it like exists already, so we don't have to do anything. Right, like we didn't deprecate FX Symbolic Trace; it still exists. It's fine.
Yeah, but I think I think there's uses in Torch Compile. There's uses in like it's still usable in Torch Compile as well. So I guess there's the question of like if it's useful, it seems like we should like Torch Compile should be able to provide it as well.
Jerry?
Yeah, I can provide some context from quantization. I think the point I see from this is like it has better coverage than Symbolic Trace. This one, and the other is the if we have we can work with the Torch API, and it's more stable compared to the A10 API because the A10 IR, because like if people change the implementation of all these Python like PyTorch modules, functionals, it will affect the A10 IR, the pre-AutoGrad A10 IR that we get. But
I would not say that the Torch IR provides superior stability to anything because of the sort of like that's explicitly not part of the contract that we talked about above, right? So I would
actually that today, because Predispatch IR doesn't exist and we're actively developing it, Predispatch IR does not have very much stability today. I think eventually it'll be a pretty stable IR, but I think for the next 6 months, it's going to be a rapidly
changing. Predispatch IR what JIT Trace produces, or am I wrong about that?
Sorry?
Does JIT Trace produce Predispatch IR?
Actually, it does.
That's correct.
They are right next to each other in the
stable and successful IR is what you're telling me.
Well, no, but we were talking about functionalization to it, and that's it's going to take some time to we're going to be iterating on functionalization. We're going to.
I think that's fair.
Yeah.
In the short run, I would not consider it to be stable. That's definitely.
It is not a stable.
But there's a question of like fundamental design like characteristics, right? Like as a fundamental part of the Torch IR design, it's not stable. Whereas at least I know that A10 IR could be made stable.
From what I heard from Brian, he says like if we change any implementation detail in Python, like Python modules or the functionals, it will change the A10 IR we get, right?
Yeah, actually, like the way stability is defined above, I don't think it can be stable because if we change an NN module implementation, it'll result in a different graph.
I mean, sorry, if we change the implementation of an internal thing, then yes, like any of these could change. The question is like, is the graph stable from run to run, right? Or no?
No. The stability before was like the stability guarantee we talked about above that we just said no The reason why we said no is because I could basically change any module implementation.
Yeah, but Torch API, we stop at higher level, right? We stop at modules. Like if I just look at n linear, it won't change. Like even if people change the n linear implementation, I will only see n linear.
Yes.
Right.
Yes. But by that definition,
yeah, that's what I mean here.
Yeah, I would say that there's the question of stability has like multiple levels. Is the execution of a given graph stable across different, sort of like revision hashes? And then is the tracing process stable? I would say, yeah. So in the case of the tracing process, with respect to changing torch NN linear, I would say that A10IR is less stable. I think that's a relatively ridiculous thing to premise anything off of, because we're not really going to change torch NN linear. But
we do change stuff like scaled out power detention.
Yeah.
There are modules we do change.
That's fair.
So may I say something? I feel the fundamental tension is we have Torch IR that works, that's adopted, but we don't like it for various reasons. We want to put a stake on the ground, hold the torch and go forward and say, this is the new thing, the Predispatch A10 IR that we think will be best for everybody. And it's basically these two choices. I feel the options I put forward, meaning that we output both temporarily, but we kind of recommend one another, is kind of a compromise. We're saying we're reaching the best of both worlds and make it work for a few months and see which users actually choose. So it's essentially a compromise. I don't think we can come up with a perfect solution on this.
But that's also not great when we are talking about talking with the backends and stuff like that, or other APIs that have to build on top of it, like quantization, which is also again vendor specific in a lot of the cases. So it's not like an end. They choose end-to-end path.
So quantization, because it's tied to vendors, will almost certainly have to use the Predispatch A10 IR, because that's what we're using.
Right.
Yeah.
But also know that the way it is defined today is that quantization, which is vendor specific, has one entry point in Predispatch IR, but vendors also have another entry point in delegation, which happens in a core A10 IR, and which sees all the decompositions and whatnot.
Yes. So this is my this is the fragmentation issue, right?
Right.
I would say from the perspective of quantization, you can't really rely on Torch IR if you have to do quantization like at the backend level, because the backends want a core A10 IR. Like that's why we built core A10 IR when we didn't really want to, because like the vendors wanted us to, right? So I feel like what quantization does, like the decision about Torch IR versus A10 IR, like at the front end level, should not affect quantization. It should be kind of decoupled.
But okay, Jerry, go ahead.
Yeah, just to clarify, like we have two IRs that we're working with. One is the part that people annotate which part of the model they want to quantize. The other part is like we already produce a quantized model and then we want to lower it. I think the first one is not working with the core A10.
So Michael, so the quantization works on a pre-dispatch A10 IR, and the delegation works on a core A10 IR. Pre-dispatch is like 3,000 ops, whatever today, and then core A10 would be like 150 ops. So even though both quantization and delegation are specifically targeted by vendors and they are the ones writing this, we deliberately made them target two different IRs, one for quantization, one for delegation. And the reason we did that for quantization is to support quantization with training.
And that's sort of a separate conversation, because we can't use core 10 IR because it's in for zone.
Yes,
yeah.
That's right. Yeah,
that's right.
Okay, we are 10 minutes over. We should discuss this some more, I guess, maybe tomorrow at Export meeting, if there still is one.
Let's just continue over the chat first.
Okay,
why do we need to wait for a day?
I feel we got some agreement, at least, so I'm happy about this part, but I don't know what Export is doing, so I guess we need to talk about that more. All right, thank you, everyone.
What do our viewers on Twitch think?
Someone was trying to solicit me to join some channel to get free money. All right, see y'all.